Here's another question of the Doppler effect. Let's look at it. An ambulance traveling down a road at constant speed and emits a sound wave from its siren. A lady is standing on the side of the road with a detector. The lady is stands on the side of the road. That means the velocity of the listener is zero. With a detector. So the lady is carrying a detector which registers a sound wave of 445 as an ambulance approaches her. So this is a frequency of the listener while it's approaching her, which is towards. Now, after passing her, moving away at the same constant speed, the sound wave frequency, the sound wave of frequency 380 is registered. Now, the lady registered a different frequency now, the frequency of the listener, which is 380, while it's moving away. Right, so we have two frequencies. The frequencies of the listener, there are two of them, while it's moving towards and while it's moving away. Right, so the ambulance moved and then passed her. Now it says assume the speed of the sound in the air is 343. That's important. Right, now name the phenomena that describes the change in frequency. That's the Doppler effect. Right, 8.2.1, calculate the speed at which the ambulance is moving. Let's look at the marks here. And guys, what we do not have, we're not given the frequency of the source here. We're given the detected frequency or the observed frequency by the lady while it's moving towards and away. So if you look at the marks here, it's going to be simultaneous equation. You're going to create equations here. So you're going to solve this. They're looking for the velocity of the source, right? And while you do not have the frequency of the source, the frequency of the source will be the same while it's moving towards and while it's moving away, but the difference is the registered. The one that is observed towards and away, they're going to be different. Okay, right. What are we going to do? We're going to do simultaneous equation. So it's 8.2.1. So I'm going to create an equation for towards, right? We know, guys, when we talk about towards, it's going to be plus on top and the minus at the bottom, right? And while it's moving towards, we are given the frequency. The frequency of the listener is 445, right? As it approaches 445 hertz, right? So I'm going to create an equation there. The velocity of the listener is 0. The velocity of the source is the one that is asked. And the speed of the sound in the air is 343 meters per second. Okay, let's do the equation. It's V plus and VL divided by V minus Vs times by the frequency of the source. Okay, now we're substituting. The frequency of the listener is 445 equal to 343 plus the velocity of the listener is 0. The lady was standing. And minus Vs. And we have another unknown here. So if you see here, we have two unknowns here. So that's why we cannot solve it with one equation. We have to use two equations, right? So what I'm going to do now, I'm going to make f as a subset of the formula. Okay, I think so. So what I'm going to do to make my life easy, so this and this it will be 343 fs there, and then the denominator remains the same. I hope that makes sense, guys. I hope that makes sense what I've done there. And then I cross multiply. So I'll have 343 fs is equal to 445 times 343 minus Vs. So I'll leave it like that. I'll leave it like that as an equation 1. And then let me go and create equation 2 by, it says away. Away, we know when we talk about away, the numerator will be minus and the denominator will be plus. And then we were given the frequency of the listener. It was what? Less. While it was moving away, it was 380. 380 hertz. And the velocity of the listener is still 0. And the velocity of the source is the one that we want. And the velocity of the sound in the air is 343 meters per second. Right? Now let's do the equation. FL is equal to V minus VL over V plus Vs times by the frequency of the source. And then let's substitute what we have. Substituting what we have here is, what is the frequency? Is 380. And then the speed is 343. 343 minus the velocity of the listener is 0. And the velocity of the source is the one that we want. And the frequency of the source we do not have. Okay, I'll do the same thing again here. So it's 343 times Fs, because this is going to be 0, so I'll just times that, and then there's 1 there, I'll times that with 1. So it's 343, guys. That's maths. Do not embarrass your maths teacher. So I'll cross multiply. You have 343 Fs is equal to 380 open bracket 343 plus Vs. Right, this will be the equation 2. Now if you're looking at both equations, if you're looking at equation 1, okay, let me just copy it and copy, just will paste it there. Do you see the equation 1 and equation 2? Right? Do you see equation 1 and equation 2? So what I'm going to do, I'm going to equate the two. I'll say equation 1, no way, I don't know what I'm doing. Equation 1 is equal to equation, equation 2. So what I'm going to do, I'll say 343 Fs equal to 343 Fs. Do you see, guys? This equation I had 343 is equal to that, and here I have 343 Fs is equal to that. So I equated the 343s. So I'll start with the black 3, which is this one. So I'll say 380. Okay, let me use the black color since it's black. 380 open bracket 343 plus Vs close bracket equal to this 343, the one that I copied from the top. I don't know why. Okay, 343 Fs, no. So I'm going to say it's equal to this. I'm going to take that. So it's going to be 445 times 343 minus Vs. Right? So what are we going to do now? It's going to be a distribution. So I'm going to distribute. So I'm going to say this times this, and this times this, and then this times that, and then that times that. Okay, let's do it. Let me take out my calculator quickly. So I'll say 380 times 343. So the answer here is 130,340, and then the 340 times Vs, it will be plus 380, not 40. Times Vs. So in this side now, so I'll say 445 times 343. So it will be 152,635, and then minus 445 times Vs. Guys, I hope you get that math. So what I'm going to do now, I'm going to transpose this to this side and this to this side. So I'm gonna have 380 Vs minus plus, not minus, plus 445 Vs equal to 152,635 minus 130,340, right? So minus 130,340. So the answer in this side, it would be 22,295. And in this side, when I say 380 plus 445, it's 826 Vs. And then the 22,295, we divide it by 826. So the velocity of the source of the ambulance, it's 226,99. We can say it's 27 meter per second. Guys, it was a simultaneous equation. I hope it made sense to you. Okay, now the last question, it says that the frequency, calculate the frequency at which the siren emits the sound wave. So we want the frequency of the source now. The frequency of the source, guys, you can take any equation there and you substitute the velocity. So you can take any equation, whether equation 1 or equation 2, any. Let me just take equation, the one that is nearby. Let's take equation 1 since I already copied it. So let's just cut. And we're going to paste it here. And then this is 3, 8.2.2. 8.2.2. Now that, guys, we have the velocity of the source, we'll just substitute it here and get this guy. So the first thing that we're going to do, we'll say Fs is equal to 445 times 343 minus, and then we substitute there the 27, and then we divide by 343. There was 343 right here, 343, and then we divide by 343. So you have Fs there. So your Fs there, it will be 409,94 hertz. Sorry guys, I hope this makes sense, guys. It makes perfect sense. Cheers, bye.